Good day, I am Jeremy B. Luminsa, one of the reporters of the Unit 3, the Cosmic Abundance of Element. Unit 3, we had four topics. First, we have the distribution of elements in solar system and Earth, composition of Earth, general concept about geochemical cycle, properties of common elements in Earth, and the concept of geochemical cycles. So by the way, this is the continuation of the report of my co-members, Ms. Jacel Humawan, which she discussed the first and the second topics. So I am going to discuss the properties of common elements in Earth and the concept of geochemical cycles. So let's proceed. Okay, so properties of common elements in Earth. What is element, by the way? Elements are the building blocks of all matter in the known universe and are substances that are made up of only one type of atom. So what is atom? Atom is the smallest unit of any elements. The number of protons, neutrons, and electrons each type of atom has is what it gives each element its unique properties and determine how it will chemically interact with each other. Okay, so what is matter? Matter is anything that has mass and occupies space, neither living or non-living things. It can be detected using our five senses. The sight, it can detect color or dark, the touch, the hearing, it could be loud or no sound, right? Taste, it can be bitterness or sweet, and touch, it could be rough and hard or soft, and the smell, it could be musky or peppermint smell. And matter, it is what the world is made of. The material surrounding us, the air we breathe, the earth beneath our feet, the food we eat, the water we drink, even the universe are forms of matter. Okay, there are three main states of matter. It's a solid, the liquid, and the gas. When we talk about solid, it has definite shape and a definite volume, and it cannot be compressed appreciably by moderately high pressure. It has very slight expansion during heating, and it has a high density. When we talk about liquid, it has no definite shape. It takes the space of its container and has a definite volume. It can be compressed, but only to a negligible extent by a moderately high pressure. And it has a slight expansion during heating, and of course it has a medium density. So gas, it has no definite shape. It takes the shape of its container, and it has no definite volume. It is the opposite of the solid. Then it can be compressed or expanded as pressure is increased or decreased. It has a great expansion during heating, and it has a low density. So the speed of these particles are depended on the amount of energy or heat they contain. Particles of solid are tightly packed and vibrate in place. Liquids have weaker attractive forces that allow particles to slide each other. And gases have particles with the highest energy among the three states. Okay, so as we all know, there are three states of matter, but actually it has five. The fourth one is the plasma. It has neither a definite volume nor a definite shape. And the fifth one is the Bose-Einstein condensate state of matter that is typically formed when a gas of boson at very low densities is cooled to temperatures very close to absolute zero, or the negative 273.15% degrees Celsius or negative 459.67 degree Fahrenheit. When they reach the temperature, the atoms are hardly moving relative to each other. They have almost no free energy to do so. At that point, the atoms begin to clump together and enter the same energy states. They become identical from a physical point of view, and the whole group starts behaving as though it were a single atom. So this state, which is the Bose-Einstein condensate instant. So Albert Einstein is the one who predicted the Bose-Einstein condensate in 1924 to 1925. Okay, so matter, it has two main kinds of properties, the physical and the chemical. So what is physical properties? These are the characteristics that can be observed without changing the substance into another substance. Melting point, malleability, viscosity, physical state, heat conductivity, and electrical conductivity are all physical properties. Example, here, a tablespoon of sugar crystal is sweet. When dissolved in a small glass of water, the tasteless, colorless water becomes sweet in light brown liquid. So we have here the glass of water. As you can see, it is colorless, and of course, it is tasteless. And we have here a tablespoon of sugar, the brown sugar. So let's mix it together. Mix it, and as you can see, as the sugar dissolved in water, the colorless water becomes brown or golden brown, as you can see. And if we're going to taste it, it is sweet. In this example, the physical properties of sugar, sweetness, and brown color are still observed even dissolved in the water. That is physical properties. Let's have another example. To determine the melting point of ice, we must change the ice to water. Like this one. We have here an ice packed in a plastic cellophane. If we're going to melt it, it will be like this one. As you can see, the differences between two. In this process, the appearance changes, but there is no change in composition. Like this one. And the next one, we have the chemical properties. These are the characteristics that can be observed when the substance undergoes a change in its composition. A chemical property is evident when a substance reacts with another substance. For example, magnesium can react with oxygen and produce a bright light. And another example, we have iron slowly corrodes or rust when exposed to air or a moist environment to form iron oxide, the reddish brown rust. There are some of these essential elements are required in large amount and serve as the major building blocks of life. These elements termed macronutrients, and the micronutrients or trace nutrients. So let's first talk about the macronutrients. Macronutrients include carbon, hydrogen, and oxygen, and are the elements required in the greatest amount. Over 93% of plant and animal biomass is made up of these three elements, which is the carbon, the hydrogen, and the oxygen. Other macronutrients include nitrogen, phosphorus, potassium, sulfur, calcium, iron, and magnesium. These are required by all forms of life, but in smaller amounts than the carbon, hydrogen, and oxygen. Next, micronutrients or trace nutrients, only required in a very small amounts. They are also essentials. They generate serves as cofactors or molecules that assist in chemical reactions. Among the micronutrients are copper, zinc, molybdenum, boron, sodium, nickel, and chloride. Under Earth's atmospheric conditions, many elements are found in a form that has an electric charge and are called ions. So what is ions? Ions are electrically charged because they don't have an equal number of protons and electrons. And it is an atom group of atoms or subatomic particles with a net electric charge. An atom with a net positive charge is called a cation. An atom has more electrons than proton and has a negative charge is what we call an ion. So the atoms of metals tend to form cations and the atoms of non-metals tend to form anions. But there are some exceptions. Ions of opposite charges attract each other. A body of ionized matter or a gas containing a proportion of charged particles is plasma. Monatomic ion is an ion that consists of a single atom. Polyatomic ion is an ion made up of more than one atom. Molecular ions are larger ions containing many atoms. A polyatomic an ion that contains oxygen is sometimes known as oxyanion. Deuterion is an ion that has both a positive and a negative charge. The dianion is an anion that carries two negative charge, while the radical ions are ions that contain an odd number of electrons and are mostly very reactive and unstable. Okay, so the existence of ions was first theorized by Michael Faraday around 1830. Okay, there are 10 abundant elements on Earth's crust. First, we have the oxygen with 46.10%, followed by silicon with 27.72%. Next is aluminum with 8.10%. And the fourth one is iron, the 5.8%. This is 5 is calcium, the 4.15%, and followed by sodium, 2.36%, and magnesium with 2.33%, potassium with 2.9%, and the titanium with 0.565%, and the number 10 is the hydrogen with 0.14%. Okay, so let's proceed to the concept of geochemical cycle. Let's first talk about the early history of the Earth. The preceding discussion has shown that at the time of formation of the Earth, and chemical elements already had been considerably fractionated. The universe consists almost entirely of hydrogen and helium, probably with less than 1% of the heavier element. The Earth, on the other hand, consists almost entirely of the heavier element. Helium is a very rare element on the Earth, so rare in fact that it was first discovered as an unidentified line in the Sun's spectrum in 1868. Some 30 years before it was detected on Earth, largely because it combines with oxygen to form water, whereas helium is an inert element. That rarity of helium in the other inert gases, neon. Krypton and xenon on Earth is good evidence that the Earth formed by the accretion of small solid objects or planetesimals. This process has operated throughout geological history and is probably still continuing. Okay, so concept of geochemical cycle. What is geochemical cycle? It is the pathway that chemical elements take in the surface and crust of the Earth. And it represents the movement of a particular form of matter through the living things and non-living things parts of an ecosystem. The geochemical cycle provides a useful conceptual framework for considering the course followed by an individual element and proceeding through the different stages. For a specific element, a complete understanding of its behavior throughout the cycle is one of the major objectives of geochemical research. An element may tend to concentrate in a specific type of deposit at a particular stage in the cycle, or it may remain dispersed throughout the entire cycle. There are categories and examples of geochemical cycle. First, we have the deep water cycle and the deep carbon cycle, or it is part of carbon cycle. Then we have the iron cycle and the carbon silicate cycle. We have the phosphorus cycle and the sulfur cycle. And the last two, the rock cycle and the mercury cycle. Flux in geochemical cycle is the movement of the material between the deep earth and the surface reservoir. This occurs through two different processes, the subduction and the volcanism. Okay, so what is subduction? Subduction is the process that takes place at convergent boundaries by which one tectonic plates and sink into the mantle as the plates converge. This leads to the sinking of one plate into the mantle, which create a broad range of geochemical transformation or cycling. Next is the volcanism. It is a process that takes place at divergent boundaries by which one tectonic plate separates from another, creating a rift in which molten rock or magma erupts onto the surface of the Earth. This molten rock's magma then cools and crystallizes, forming igneous rocks. If crystallization occurs at the Earth's surface, extrusive igneous rocks are formed. If crystallization occurs within the Earth's lithosphere, intrusive igneous rocks are formed, which can then be brought to Earth's surface. Geochemical cycle is a continuous cycle of elements passing through and between the Earth's lithosphere, biosphere, hydrosphere, and atmosphere. For example, sodium is released from rock or lithosphere by weathering and is transported in solution or suspension to the sea or the hydrosphere. Okay, that is the questions. And that's the end of my report of the Unit 3 Cosmic Abundance of Elements. Thank you.